Hello and welcome to the 2021st edition of Milestone Developer Conference. Today's presentation will be the showcase of development simplicity inside combined worlds of Intel and Milestone. This is how you can boost your AI analytics with Intel OpenVINO and Milestone XProtect. My name is Olszewski. You may know me from Intel's YouTube software channel and Inside AI series, but on a regular basis, I work as an AI solutions architect inside Intel's Internet of Things group focused on Edge AI. My role is to guide and support ISVs and OEM customers across the EMEA region throughout their AI development journey. Before we jump into specifics, let us briefly summarize today's agenda. As an introduction, I would like to specify why do we actually need to pay our attention to video analytics? Second of all, I'd like to explain that there is no black magic behind deep learning and computer vision. After an introduction part, we'll move on through Intel's OpenVINO and DL streamer specifics and jump into Milestone XProtect VPS, summarizing those in the part where we'll talk about how to connect both of these things and integrate your video analytics pipeline inside Milestone VMS system. After that, we'll have a short Q&A session. Video is the eye in IoT. With over 1 billion cameras installed by 2024, the opportunity for all companies worldwide is to create applications in order to move, process, analyze, and store the rich data that comes from the camera. This is where edge inferencing and AI happens. All these cameras, they're not suited with AI analytics capabilities straight away. They need you, developers, to apply intelligence inside. The total available market value predictions for 2024 is $30 billion. The question is, will you hop on the train or not? Because people are riding it already and it's going fast. And I mean 28% year on year fast, and it's not stopping anywhere soon. For those who have already rich experience in creating deep learning-based applications, the title above may be slightly misleading. However, if you're still on the side that you think creating comprehensive, robust, and high-performance video analytics is hard, it's about time you change your way of thinking. It's all about keeping things simple. Let's take a look at the standard time to solution chart of an AI application and drill down a little bit on each of the sections. So first, sourcing the data, that's an obvious start, since you need some data set to train your AI model with, and later on to test out an inference part for further benchmarking, hypertuning, and documentation. It's the most troublesome part of development cycle, since depending on your needs and application use case, you may encounter various challenges regarding data quality, pre-processing, labeling, and annotation, and of course, data privacy, so GDPR. Model development is the core part of an innovation cycle. Usually consists of several steps, including data pre-processing for model training, model topology adjustments for example, how many layers in which order and shape should I use? Tuning hyperparameters, so the optimization part, of course, documentation, and so on. Apart from the most time-consuming part, not included here, so model training, which can take double the time spent on the model development. Massive amount of work and challenge needs to be done prior to the inference development and deployment, of course. Finally, integration, which can be especially challenging in distributed edge computing systems without appropriate software support. Sounds complex? The fact is, not only you can substitute this whole innovation cycle effort with one single toolkit, but half of the journey has already been done by Intel and our ecosystem. The only thing you need to do is to choose the right building blocks and a way you'd like to combine them. So you don't need to worry about integration, since Milestone equips you with all required software tools. The only effort that you need to deal with is the deployment part. Or not. Because Intel OpenVINO Toolkit does it for you as well. Before we jump into details, let's take a look at the very end of the time to solution pipeline and talk about integration. The MIP-SDK, so Milestone Integration Platform documentation, is your entrance to the Milestone Integration Platform software development kit. And this is where you find inspiration and solution for your specific development tasks. MIP-SDK enables you fast and flexible integration between Milestone XProtect video management software, applications available from the Milestone marketplace, and other third-party applications and devices like your AI application, in fact. To provide maximum flexibility and allow optimal integration of different types of systems and applications, the Milestone Integration Platform offers three main integration options. If you run all your application on a known Windows environment and you want to stick to your own app design principles, you can access the Milestone Video Management System configuration, get live or recorded video, and send control commands as well as events to the Milestone server through protocol integration. A convenient and easy way to integrate your application with MIP components can be done through component integration, especially useful when end-user application is developed by others than Milestone. Then MIP components can be used for interacting with the Milestone servers and use libraries provided by Milestone in your Windows-based application. The most refined integration method is through plugin. This allows you to embed your plugin into the Milestone XProtect management environment and run your plugin as an integrated part of the XProtect software and its client applications. It's all flexible, easy, and fast. So once you've been given all these tools and platforms to get your application up and running, what do? There are dozens of different face, gender, age recognition apps running across the whole ecosystem already. What do you do with them? In fact, flexibility of Milestone VMS environment allows you to utilize your applications in many ways. You can, of course, go down the simple path. Based on different kinds of inference events caused by detection tasks, for example, whether if it's a face or other object, you can trigger specific actions like alerts or your system notifications. But if you want to do things a little bit differently, you can also utilize the fact that the Milestone Integration Platform is now supporting metadata-based search engine, thanks to which you can turn your smart client into a centralized intelligence center that can show you any face or any object at any time you want. One of the great examples is SAIMOS centralized search engine. So now let's jump into a different presentation for a second and let's hear Mr. Jürgen Konechnik, SAIMOS CTO, talking about their innovation.
Now to the search integration. And what we have here now is two fully independent plugins to search for license plates and for faces. So now this enables us to utilize our metadata and also data from Milestone together within the centralized search. So if I go in here and create a new search, it is possible for me to get all the data out that would normally be just limited to our log, and we can basically look at the data that the system creates for us. So for example, this is like me in the office or my colleague coming in. And of course, we can also filter here. So we could go, for example, only for recognized persons. So you see here that this was where the system actually recognized us. But you can also go for age classification and say, okay, where are the old people in the room, for example. And we can get from, this is now a different camera, we can get all the old guys, for example, if we want so. Or we can clear that up and go, for example, for only females, and we will get females within the system. Of course, there's also the possibility of searching by label.
Jürgen,
yeah.
I'm sorry to interrupt you, but I think I was going to ask this question during the Q&A session, but I think it's very relevant to what you're showing now. One of the questions is how face detection is treated in accordance with GDPR. Because obviously GDPR is a very important topic. So while you're at it, please explain.
So in essence, if you're utilizing face detection, you of course have to have the permission to do so, or have to have the incentive to do so. So in essence, if you ask me personally, GDPR compliance is of course possible in our system, because if we would go, for example, to our web interface, you can of course go into the database maintenance and basically tell the system how long it should keep the data. In essence, it's also as soon as you are doing face detection with faces stored in the system. So like I'm doing now, you have to have the proper GDPR permissions for that. So I'm not a lawyer, so I cannot tell you that. But if you're utilizing our face detection and recognition internally or externally, so for example, within your company or externally, of course, you have to have the permission to do so.
Now let's jump into specifics of Intel OpenVINO, so Open Visual Inference and Neural Network Optimization Toolkit. In a nutshell, this is all you need to know about the OpenVINO. It's supported by all the most popular frameworks, it's supported by any Intel hardware, and it's supported by any kind of operating system. This is a key part of an Intel AI software ecosystem. So I'm going to take you on a developer journey now and show you how easy it is, in fact, to deploy an AI application with Intel OpenVINO Toolkit. First of all, building blocks. A couple of slides before I mentioned that Intel has already done that job for you. To be more specific, we created a repository called Open Model Zoo that contains hundreds of pre-trained models supported by the popular frameworks. 280 plus pre-trained models exactly. Object detection and recognition, text and speech analysis models, image segmentation, human pause estimation, almost any kind of use case you need is there. The next part of our journey is optimization. Take your pre-trained model or trained model, optimize it, and run it on your base hardware, namely CPU and integrated GPU, without necessity to plug in additional accelerator. The model optimizer returns a form of a process model, which is called intermediate representation, an XML file with network topology and binary file with model weights and biases. That is later on being used by an inference engine to perform detection or classification actions. Deployment part, as stated before, is also something Intel can help you with. Inference engine is a high-level runtime API based on C, C++, or a Python code that is implemented as dynamically loaded plugins for each type of the hardware. Of course, these are not the only things and ingredients inside the OpenVINO toolkit. You can find also additional elements, such as if you need to train your own model for data collection and pre-processing, you can use computer vision annotation tool and dataset management framework. For training, you can utilize OpenVINO training extensions. For deployment, you can use and take the leverage of Deployment Manager to create an optimal runtime package with minimal footprint. Model serving is a distributed system that can be done through an OpenVINO model server. For building video stream analytics pipeline, you can utilize Intel's deep learning streamer to create and deploy complex media analytics. And that is what I would like to focus in the next section of our presentation. Let's take a deeper look into the OpenVINO DL streamer. So what it is exactly? DL streamer is one of the core components of our OpenVINO toolkit. It's a video streaming analytics framework based on a standard GStreamer library with minimal pipeline interoperability, with a familiar developer experience built using the GStreamer multimedia framework. The objective of DL Streamer is to enable developers to develop and implement and optimize streaming media analytics pipelines across the full spectrum of Intel hardware, including and reduce the time to market significantly. Let's go into more detailed picture in order to understand how DL Streamer works and how the software stack in DL Streamer is organized. DL Streamer is based on a standard GStreamer open source frameworks, which allows DL Streamer based applications to construct a flexible pipeline utilizing a rich set of standard GStreamer elements and new components provided by DL Streamer called GVA plugins. Plugins span across object detection, classification, and tracking. GVA plugins for metadata handling include also metadata conversion, publishing, and rendering for data visualization. Standard GStreamer library and elements rely on native APIs and runtime libraries, including VAAP and libav. For codec implementation and video pre-processing, they utilize OpenVINO engine and OpenCV libraries. The first three GVA plugins are the inference elements based on the OpenVINO inference engine. The GVA inference is a generic inference plugin responsible for processing any kind of model processed through an OpenVINO inference engine. It attaches an appropriate metadata to each frame and can process any kind of frame captured in an RGB or GBR color space format. GVA detect is a more specialized element which is responsible for object detection or recognition based classification. It outputs a list of detected objects including their class and bounding box coordinates, as well as associated timestamp metadata. GVA classify takes the frames based on detection together with a list of bounding boxes and classifies detected objects. GVA track is used for tracking detected objects and consists of two predefined tracking algorithms. So-called zero tracking element assigns unique IDs to detect objects and helps to build object trajectories across multiple frames. That requires object detection to be performed for every frame, but there is a solution to that. A short-term tracking algorithm facilitates the tracking of object positions between inferences, so there's no need to make object detection for every frame, but every 10 or 20 frames, for example. Next, we have three metadata processing plugins. GVA Watermark is responsible for metadata visualization. It reads metadata attached to incoming video frames and overlays the object bounding boxes, labels landmark points onto the video frames, and produces a modified video stream that can be stored and sent back to the VMS or service clients to visually observe the output. GVA MetaPublish enables you to save metadata as a file or push the metadata stream in real time to Apache Kafka platform to be transmitted by a Kafka stream. You can also format into the MQTT protocol and make an upstream through TCP/IP to a Kafka broker. Last one, GVA Python inserts a custom Python functions into the pipeline, thanks to which you can invoke your own Python-based functions on every frame. Let's take a look at the standard architecture of video inferencing pipeline, including DL Streamer elements, and underline the most performance-critical areas. The stream falls into the sync path and is handled by the DL Streamer inference elements, namely GVA Inference, GVA Detect, and GVA Classify. These elements perform necessary pre-frame pre-processing, so image calling and color space conversion, which depend on the neural network model we are using. Resize and color space converted frames are being passed to the underlying inference engine backend into the inference request queue. Once the inference request is complete, the engine outputs the frame and passes it for necessary post-processing. Once that is done, the received metadata is being attached to it or synchronized by means of the timestamps. Now, what if we need to process a certain number of streams in parallel to analyze video streams coming from multiple cameras? Normally, we will end up with overall pipelines being duplicated by the number of streams, including an inference element. That can overwhelm your compute power. In this case, using OpenVINO Toolkit with DL Streamer, allows you to create only one instance of the inference engine, which is shared among all parallel streams and processes all the frames coming into the inference request queue. That allows you to reduce the overall memory consumption and increase analytics performance and efficiency. Let's go straight in a short demo of video analytics pipeline sample using the DL streamer. Here we have an example of a pipeline that performs face detection based on which recognizes person age, gender, and emotions. It also subsequently classifies facial landmarks, which then can be used for a further analysis. First, I need to denote that the GST launch tool that is used here usually builds and runs basic GStreamer pipelines. It's primarily a debugging tool, and it's not really targeted way for building applications. You can, however, use it for constructing test pipelines, as it can be very easily implemented inside any C or C++ application. Of course, we start building our pipeline with a source file, in this case, file called video.mp4. Then you want to decode the file stream, and for that, you'll use the decode bin element. The first inference element is GVA detect, which performs a face detection ask. In this case, we're using one of the pre-trained models from the Open Model Zoo. GVA detect outputs the bounding boxes for detected objects. In this example, faces, which are later on used as an input for 3 subsequent GVA classify elements. At the end of the pipeline, there is a queue element. At the end of the line, there is a queue element, which is a core component of the GStreamer framework. It creates a new thread on the source path, decoupling the sync and the source path, allowing for asynchronous work of our analytics pipeline. Next, we want to perform age and gender recognition, emotion classification, and face landmarks regression using GVA classify element. Please note that for each of the elements, we specify targeted device on which we would like to perform classification. When specifying inference requests using OpenVINO API, you can choose your CPU, an iGPU, or a multi-device plugin, which can take the leverage of both engines to perform a single inference task, which increases the performance in the overall matter. At the very end of our pipeline, we convert our metadata into a JSON file using GVA metaconvert and publish it through MQTT or a Kafka broker using GVA metapublish. Here you can see an example of what the metadata is being converted to and then published. As an alternative to that, we can use GVA meta. An alternative to that is to use GVA watermark instead, in order to overlay the metadata on the frame and display it as a live face detection feed. That exemplifies how easy the pipeline modification is and how that can translate into your development time saving. Once again, an alternative to that is to use GVA watermark instead, in order to overlay the metadata on the frame and display it as a live face detection feed. That exemplifies how easy the pipeline modification is and how that can translate into your development time saving. Now let's take a look at one of the components of MIP-SDK, the video processing service framework called VPS. VPS is a set of tools allowing to connect an external compute platform using an open source GStreamer framework to build custom video analytics pipelines. Video and/or metadata output from the GStreamer pipeline can be brought back into the XProtect VMS through a VPS driver-based device. In a short description, video and metadata is being captured by a camera driver and forwarded to be optionally recorded on a disk or sent as a live feed to the smart client. Then the VPS toolkit adds the ability to forward the feed unmodified through the VPS driver. The VPS driver pushes the video to a VPS service, which then can be processed through video using GStreamer pipeline. Optionally, the video and/or metadata output from the GStreamer pipeline can be sent back through the VPS driver into the XProtect VMS. And yes, it comes together with samples explaining how to perform video analytics using VMS XProtect together with VPS and DL Streamer. Speaking of, now let's see how we can combine those two things to easily make a metadata and let's see how can we combine those two things to easily make a media stream analytics pipeline. How do we do that? Very simply, all you have to do is to replace the front end and the back end of GStreamer based video pipeline elements with from XProtect converter and VPS meta from ROI plugin, which provides linkage to the VPS app sync and app source. And off you go. You just integrated your video analytics pipeline into the Milestone XProtect VMS. Let's summarize all the steps of our journey. If you want to easily build a high-performance video analytics pipeline, just follow the steps. First, get one of the models from our Open Model Zoo. Second, process it via OpenVINO Model Optimizer. Then, build your video analytics pipeline using DL Streamer elements that will execute inference on the OpenVINO inference engine. Finally, you have to build your application to control the video analytics pipeline and integrate it into the XProtect VPS easily, as I just showed you on the previous slide. After that, the only thing that is left to do is to license your software and sell it. That's the whole story. You need to know that the video market is rapidly changing, but has been behind on technology. There is a lot of older technology in the market that cannot handle today's algorithms in or outside the camera. That changes with Intel and Milestone today. If you want to know more, just check out the links provided below or scan the QR code shown in the slide. You can also reach out to myself anytime you want to know more about Intel's AI capabilities. Thank you so much for your time today and stay safe.